Hey, it's Zach, and today we're talking about switches. Why switches? The answer to that is that switches are vital to creating electronic circuits from the most simple to the most complex. This video is designed to give you a solid foundation about switches that will set you up for success for any electronics project that might require them. So enjoy, and don't forget to like, subscribe, and click on the notification button for more electronics videos. This video is broken down into 3 modules. Module 1, Basic Switch Terminology. Module 2, Types of Switches. Module 3, Basic Switch Applications. What is the definition of a switch? A switch is an electronic component that connects, interrupts, or diverts electrical energy within a circuit. Switches are characterized by their number of poles and their number of throws. A pole is the input terminal of a switch, and the throw is the output terminal of the switch. Based on the combinations of poles and throws, switches can perform various functions. When the number of poles or throws equals 1, the letter S, that stands for single, is used. Then when the number of poles or throws equals 2, the letter D, that stands for double, is used. If the number of poles or throws exceed 2, which happens in certain applications, integers, such as 3, 4, or 5, are used to describe them. Examples include single pole single throw, single pole double throw, or 3-pole single throw. Basically, switches can have any combination of poles and throws imaginable. Now let's talk about what it means when a switch is normally open or normally closed. However, before we can understand what that means, we need to understand what an open is and what a closed is in electronic circuits. An open is a location in the circuit where there is no path for current to travel. As you can see on the diagram, the switch creates an open. Therefore, the light bulb is off because no current can travel to it. When that open becomes closed, a path is formed allowing current to travel. As you can see on the diagram, the switch creates a close. Therefore, the light bulb is on because current can travel through it. Based on these definitions, a normally open switch prevents current from traveling in its resting state, while a normally closed switch does the reverse and enables current to travel. Then once the switches are actuated, the normally open switch will become closed and enable current to travel, while the normally closed switch will become open, preventing the flow of current through the circuit. The last piece of basic switch terminology you should be aware of is the center-off position. The center-off position is an additional position where the pole does not connect to any throws. Now let's discuss common pole and throw configurations you may see. The first one we'll look at is the single pole single throw switch. This switch is designed to create an open or closed configuration in the circuit. Then we have the single pole double throw switch that diverts current from one circuit to another, or both if there is a center-off position installed in the switch. As a final note before moving to Module 2, ensure that the switch you select is appropriate for the voltage and amperage of the circuit. It's not just enough to know the pole and throw requirements of switches. It's also necessary to know about their various types and how they operate. The first type of switch we will discuss is the push-button switch. In a push-button switch, a person presses the button on the switch to either create a close or an open in the circuit. The mechanical limit switch opens or closes a circuit when physical contact is made between an object and the switch. While it's common for limit switches to be actuated through physical contact with an object, they can also be actuated by pressure, temperature, or even by water. A toggle switch uses a lever to create an open or close in the circuit. Unlike a push-button switch that will spring back to its original position after you press it, the toggle switch will remain in the position it was moved to and will only move back to its original position if someone moves the lever again. A rotary switch is operated by rotation. By rotating the switch, the user can select one or more circuits out of many to contact the pole. In the picture below, the driver would use the rotary switch to switch from park to reverse, neutral, or drive. A magnetic reed switch is actuated by a magnetic field near it. For example, the open reed switch shown below closes in response to a magnetic field. The next topic we will talk about answers the following question. What interesting applications can switches be used for? For starters, a push button is pressed on a calculator, causing a circuit that is normally open to close. This closed circuit then enacts a function or number pressed. For example, the calculator enacts a circuit that enables a 3 when the 3 button is pressed. Another common but important application of the push button switch is actuating a doorbell. When the switch on the doorbell is pushed, a circuit is closed, triggering a sound that lets you know a person is outside. A mechanical limit switch is vital for elevator operation. On an elevator shaft, a limit switch is placed on top and on bottom. When an elevator reaches the bottom, the limit switch is actuated, preventing the elevator from crashing into the ground. When it reaches the top, a limit switch prevents the elevator from crashing into the ceiling. Essentially, a pair of limit switches keep riders safe by ensuring the elevator stays on track. It can also be used to activate a sump pump that pumps water out of a sump. For those that don't know what a sump is, it's a pit that collects liquid such as rainwater. It would be impractical and costly to run the sump pump all the time. Therefore, a limit switch that actuates a circuit that triggers the sump pump when water reaches a certain level is used. By using this switch, the sump pump only discharges water when necessary. While this is a limit switch, people also refer to this type of switch as a float switch. A rotary switch is why your laundry is not ruined after its first couple of washes. By rotating the switch, it allows the user to use warm water for one wash, then cold water for another, thereby protecting your clothes. Your home security system is enhanced because of a magnetic reed switch. When a door is breached, the normally closed magnetic reed switch on the door frame becomes open after the magnetic field is removed. Once the open is created, the circuit becomes actuated. I'm excited about producing these videos. If you'd like to see additional videos about a specific topic, let me know in the comments below. Also, don't forget to like, subscribe, and click on the notification button for more electronics videos.